Hi, welcome to my video on word problems on sinusoidal functions, part 3, extra 1. Let's go over some word problems. A Ferris wheel rotates once every 8 seconds, reaching a maximum height of 11 meters, minimum height of 1 meter. The speed is constant. Find the equation to represent the height above the ground if at 2 seconds the wheel has a minimum height. The height is a sinusoidal function. So what we have is that we have every 8 seconds, so the period is 8 seconds. It has a maximum height of 11 meters. It has a minimum height of 1 meter, and it reaches its minimum height at time of 2 seconds and is at its minimum height. That's important because if it starts off at its minimum height, then that means it's going to be a cos equation and it's going to be negative. So we start off, let's find the average. In other words, if it has a maximum height of 11 and a minimum height of 1, so the average is 12 divided by 2 is 6. So that means that the height of the axle is 6 meters. And that means that's the sinusoidal axis. So that means K is 6 because the height of the axle, the radius of the wheel, keeps moving around. Okay, we have that. We have K. Now, we also have what we call the amplitude. But the amplitude in terms of a wheel, the amplitude is the radius of the wheel. So the amplitude is the maximum height of 11 minus the sinusoidal axis. So the amplitude or the radius of the wheel is 5 meters. And as a result, we have what we call it's a minimum height. So going from the minimum height, that means we have a cos graph, and because it's a minimum height, it's going to go up. So that means we have an up, that means we have a negative. And as a result, that the A is going to be a negative 5. And we have the time, so that means the H is 2 seconds. So we also have a time of 2 seconds, so the period is 2 pi divided by B. So if the period is 2 pi divided by B, the period we said was 8 seconds, so we have 8 equals 2 pi over B over 1. That's a B now, not a 6. So 8B equals 2 pi. So B is 2 pi divided by 8. So B is pi over 4. So we have A, we have B, we have H, and we have K. So we have the equation. So the H of T, if you want to do it as a function notation, the height in terms of time is A, it's a cos equation because it's from the minimum, B, T minus H plus K. So A is negative 5, cos, B is pi over 4, H is 2, so minus is going to be the opposite, and K is 6. So that's the equation that represents the rotation on this problem here, this wheel. Okay, let's try another one. Number 2. A ball is floating on a pond which has a depth of 8 meters. The wave has a crest height of 1.2 meters. The ball moves up and down once every 2.6 seconds. Find the equation representing the motion of the ball, which is sinusoidal, in terms of the distance from the bottom of the pond. So what we have a crest height of 1.2 meters, and we have the period that it goes up and down as 2.6 seconds. So let's draw a picture. Let's look at this as being, this is the water level. It's the level of water in the pond. And it says that this is the bottom of the pond. So what we have, the distance from the pond is 8 meters deep. Okay, so there's the pond is 8 meters deep. And the ball is floating up and down. So the ball, pretend the ball is right here. So the ball goes up, hits the height, it comes down to the water, it goes up again. So the ball has this motion. So what happens is that this is the crest height. So this is 1.2. So that means that the maximum height of the ball from the bottom, the maximum depth height of the ball from the bottom is 8 add on 1.2. So the maximum is 9.2. The minimum height is 8, because the ball will go up, come down, touch the water level, and go up again. So that means the average between the max, which is 9.2, and 8, the average is, if you add it up, you get 17.2, and that gives you 8.6. So that means that 8.6, that's the height, that's the sinusoidal axis. So that means that K is 8.6 meters. So we have a maximum, that is maximum height. That means we have a cos graph, and that means if that is maximum height is coming down. So that means we have a plus. So that means A, which is its amplitude. Oop, I didn't get its amplitude, so let's go and get the amplitude. The amplitude is, let's go and get the amplitude. So the amplitude, I forgot to get the amplitude. The amplitude is the maximum height, which is 9.2. Subtract the amplitude, which is 8.6. So that's 0.6. So the amplitude is 0.6 because it's positive. That means A is a positive 0.6. And we have, to start off, we're taking this point as to be the 0, so the H is 0. And the period is 2 pi divided by B. So the period is 2.6 seconds equals 2 pi divided by B. And that means that we go up right here, 2.6 B equals 2 pi. So divide by 2.6 on each side. So it's 2 pi divided by 2.6. That's pi 1.3. I divide by 2. And that's equivalent to, because that's a decimal, if you multiply top and bottom by 10, you get 10 pi equals 10 pi over equals 10. 10 times pi is 10 pi. 10 times 1.3 is 13. So B is 10 pi over 13. So now we have, do we have A, which is the amplitude? Yep. Do we have B? Yes. Do we have H? Yes. And do we have K? Yep. So we have the equation. The height of the ball above the bottom is A cos B T minus H plus K. So A is 0.6 cos, B is 10 pi over 13. H is 0. And K is 8.6, which is the sinusoidal axis. The sinusoidal axis, if you think about it, is right in the middle here. So that's halfway between here and here. So it's 0.6. 8 plus 0.6 is 8.6. So the final equation, the h of t, 0.6 cos 10 pi over 3. T minus 0 is just t, and add on 8.6. So that's the equation that represents the ball floating on the pond. So notice I draw a picture, and from the picture you get a feeling of seeing the sinusoidal wave here forming by the ball. And we have another one to do, so let's straighten this up. A fishing officer observes a dolphin swimming pattern as sinusoidal. The maximum height of 0.6 was reached a half a second after it came out of the water. Find the equation which represents the path of the dolphin in terms of his height. So we have a maximum height of 0.6. I could have meters. I have meters, but I could have feet or anything at all. I just kept to the metric system. And the time that it does that is half a second after it comes out of the water. So let's draw a picture of a dolphin swimming. So here's the water level. Now a dolphin is coming up out of the water. So a dolphin goes up, hits this maximum height, comes down to the water, goes underneath the water, and comes up again, forming this sinusoidal pattern. So it reaches its maximum height right here. The maximum height above the water is 0.6. That's the maximum height. But it reaches that at a half a second. So this point right here is a half a second and 0.6. Okay, so we have the sinusoidal axis is right here, which is the water, right in the middle of the water level. So that means the sinusoidal axis is the height equal to 0. So that means K equals 0. Notice the amplitude is the height above, so the amplitude is 0.6. So A is 0.6. And it happens that the H is half a second, because a half a second after it comes out of the water. But it takes a half a second to go here. It takes another half here. It takes another half here. And another half here, because the time to go up and to come down again is going to be the same. So that means that 1/4 of the period is a half a second. So if you multiply by 4, 4 times a quarter is 1, 4 times a half is 2. So the period for the dolphin to leave the water and come back to the surface of the water again is a half is 2 seconds. So that means that if the period is 2 pi divided by b, so that's 2 pi divided by b, that's 2 over 1. So that means that 2b equals 2 pi. That means b must be pi. And again, it's coming from it's reaching its maximum point, maximum height, which is a cos, and it's going down. So that means it's positive. So that means that A is definitely positive 0.6. Up here we know that we said the amplitude was 0.6, but we didn't know it was positive or negative, but now we do. So the equation is y equals A, it's a cos graph because it's coming down from the maximum, B t minus h plus k. So a is 0.6, b is pi, t, h is 0. Oh, sorry, h is 0. H is a half because it's a half, so it's a minus a half, and k is 0. So when I say y, I could have the height, I could say, instead of saying y, I say the h of t is the height in terms of time, the h of t. So the final equation, simplified, 0.6 cos pi t minus a half plus a 0. We don't put the 0 in. So that's the equation to represent this the swimming pattern for the dolphin. So there's 3 problems that we reviewed, and notice all the word problems are in terms of 2 pi over b, because the graph of the equation, the horizontal axis is not theta, the horizontal axis is in terms of time. And again, if you like my video, click the like button. If you're not a subscriber, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video was of some help to you. Bye-bye.